Hey, what's up, guys? Back with the videos again because I got freaking laid off. Um, but so yeah, time to grind lead code again. Might as well start doing these videos again, practice talking through my answers, and just kind of exposing myself for not doing well on problems. Yeah, let's do it. You know the deal. Random medium problem that I have not done before. Uh, JavaScript, no thanks. We're looking for some DSA. Cool, cool, cool. Looks normal. 48. Uh-oh, I'm gonna get cooked. Whatever. We're doing it. 15 minutes on the clock. Here we go. Minimum cost to equalize arrays using swaps. You are given two integer arrays. You can perform the following two operations any number of times on these two arrays. Swap within the same array. Choose integer, blah, 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 or nums2i and nums2j. This operation is free of charge. Swap between two arrays. Choose an index I, swap nums1i, nums2i. This operation incurs a cost of 1. Ugh. Okay. Turn integer denoting the minimum cost to make nums1 and nums2 identical. Oh, excuse me. Sorry. Alright. So then note here, swapping within the same array, no cost. So the indices with like the initial indices don't really matter. So could help maybe sorting or something. Like we don't have to keep everything in the same spot. We can move things around within each array. Return an integer denoting the minimum costs. Blah blah blah. Return it could be not possible. Alright, that's something to note. Also, should I metagame this and look at the constraints? Probably not. Probably not. Anyways, before I even excuse me. I was gonna say before I even look at the output, I was gonna try to figure out what the answer would be for this one, but then my eyes looked at output 0. But it makes sense, right? You can just flip around 10, 20 and get the same kind of list. And I see output 1. You know, I'm trying to scroll up so I can't see it, but I just can't help but look. So let's see why. We're gonna have to switch. Okay, you know, sorting doesn't even freaking matter. Let's just count the frequency of elements, right? And if the frequency of elements can't be balanced, meaning the frequencies are not 0. Oh, I feel like I did a problem like rearranging fruits or something. I don't remember. If the frequency of elements can't be balanced, then you should just return -1 also. It's just a frequency problem, I believe. Show me an example 3, and I won't look at the output. Show it to me, yes. Okay. 10, 20, 30, 40. It's not freaking possible. Show me example 4. There's never an example 4. Alright. Yeah, I think, like... Alright. This is easier rearranging fruits. Because we don't have to do the stupid thing where you, like, do some stupid things. Alright. What's the game plan? We need the frequencies of nums1 and nums2. And we just need to find how much needs to get transferred for each element. Isn't that right? I believe that's right. Okay. So we'll do something like this. It's just so easy in Python. I'm saying that, but I'm gonna get it wrong anyways. We have our counters. There's a chance that like I'm trying to figure out how to iterate through all the keys because I want all the keys. And you know what I'm gonna do? I'm just gonna do something stupid here. I don't know if this will work. No, probably not. So, you know what I'll do? How else can I do this? Create a set and then update, right? Okay, so we're gonna go through all the keys. We're gonna do, yeah, we need the total. So it's early in the morning and I can't type. So if it can't be balanced, we should just return -1. So many typos, oh my gosh. And why is this not here? Okay. And then otherwise we just need to figure out how much it gets transferred. How do I figure that out? Let's say there's a total of 6. My list 1 has 2. List 2 has 4. I would need to transfer 1. How do I do the math here? Oh, I think I just subtract and divide by 2, right? So we'll have a result, which is this, and then this is going to be absolute value, because I don't want to keep track of which one has more. Something like that. I believe. Something like this, maybe. Let's see. What am I doing wrong? If it's 2, expected is 1. Oh, because it swaps over and it has to take the spot of something else. Okay. Low key, I think we can just divide this by 2. Yes! And okay, so why can we just divide this by 2? Because we're double count, or like, every time we swap, every time we swap, like we're like ideally swapping with something that is also not ordered. So we're kind of like killing 2 birds with 1 stone. I don't really have a great way of proving that, but yeah, basically like every time I'm swapping here, like I'm swapping the elements that I want, but also I need to move elements to allow the swap. And when I'm doing that, I might as well move elements that should have been swapped also. So I'm just double counting. And so if I just, you know, divide by 2 to undo the double count, then it works, I guess. I'm not too happy about that though, because I wish I could explain that a little bit better. Does this work? No. Is there a way to make this work? Don't care. And then let's see, time complexity, creating the counters. So of n, call nums 1. Wait, they're the same length, right? Both sides n. Yeah, so of n plus n, so just of n. Size of this, I'm like, I low-key overcomplicate in my head, like how to measure the space complexity of dicks or like maps. I have like a little cheat sheet I'm trying to find, but I kind of like, I don't know, I think I'm just overcomplicating it. Where is it? Really hope I find it. Hold on, one sec. Yeah, I can't find it, but let me think. Because like there's something to do with like the amount of time creating the hash for each key and the amount of keys. So that's one thing. No, that's part of the time complexity for creating the dict. So how long does it take to hash? Am I hashing here? Numbers, right? I really don't know. I think it's, I don't know. I think it's constant time, maybe. It's not constant. Is it constant time? Maybe. Maybe it's like log. It's probably log. No, it's not. No, it's not. Okay. Anyways, I'm freaking out. I don't think it's that complicated. It should be just like, we're just gonna call it oven space. I think it's oven. And then this is all oven behavior as well. Going through all the keys. This is ov 2n, whatever, oven, blah blah blah. Sounds good. No editorial. Rip. Kind of. Let's see the hints here. Frequencies. Yes. Oh, divide by 4. You're right. I could have done that. Whatever. I'm sticking with my way. You just singular hash out sort of div of frequency. How do you do that? Because that would require a lot of time to check the different frequencies without using other hash maps to do it. You could use like a big list. I don't really know. Whatever. I think we did it. Did the problem. Good job and goodbye.